MTTR 54 Behaviour of Metallic Structures. In this video, we link the typical properties of metals to the way their atoms are bonded. They tend to be much denser than other solids. They conduct heat and electricity. They bend and stay bent without breaking. We say they are ductile. They are normally solid at room temperature and fairly easy to melt, but very difficult to vaporize. They are shiny. If you hit them, they have a metallic ring sound. All these properties arise from the way the metal atoms bond. A typical metal atom has an outer electron shell which is less than half full. When two metal atoms approach, an electron pair bond will form. As other atoms approach, they too will be attracted in because there's space in the outer shells of both atoms for more electrons, but never enough to fill the outer shells. So you can go on adding atoms as much as you want, enabling metals as elements to form closely packed metallic crystal structures where the atoms are bonded by a sea of electrons in these partially filled outer shells now spread over the entire metal crystal structure. Yes, metals are crystalline. Next time you pass a galvanized railing, look carefully to see the crystal grains of zinc on the surface of iron. Let's now relate the 6 properties of metals to their bonding. Giant structures made of non-metals, like silicon in rocks, have a maximum of 4 atoms surrounding each central atom, with densities about 4 times that of water. In contrast, in metal crystals, the atoms are much more tightly packed, being surrounded by 8 or 12 other atoms. Also, atoms get more massive as you go down the periodic table, where we find most of the metallic elements. For example, gold has a density 24 times that of water. But there are exceptions. Lithium, sodium and potassium are all less dense than water and float. The loose sea of electrons are available to carry heat and electricity easily through the metal, making them excellent conductors of heat and electricity. The non-fixed nature of the bonds means that atoms can slide past each other but will stay bonded. See the linked video on alloys to show this in detail, making it easy to bend or hammer metals into shape without breaking them. The bonds between metal atoms are strong, so it's difficult to separate the atoms, making them hard to vaporize. However, the bonds are not fixed as in other giant structures, so most metals melt fairly easily with the atoms sliding past each other but still in contact. In fact, some metals, like mercury, are liquids at room temperature. The loose electrons can absorb and re-emit light of all wavelengths. It is a metal at the back of mirrors that does the reflecting, not the glass. Sound waves can travel fast and easily through the simple, tightly bound metal crystals, good for making bells and cymbals.